Do aliens actually exist? It sounds like a simple question. Most people believe that one way or another, aliens do exist, whether that means an advanced civilization or simply microscopic organisms. Either way, if it happened here on Earth, then it must be possible to happen again. There have been many estimations about alien life forms, but what if starting life on a sterile world is much more difficult than those previous estimates? But just how difficult would this be? It doesn't matter where you look on Earth. If there's water, then there's life. The only way this isn't true is if you sterilize the water yourself. So it's pretty common knowledge that life requires water to survive. But why? Water is a solvent, meaning it is great at dissolving many different kinds of molecules. You're probably quite familiar with coffee or even tea, right? There is nothing better than water as a solvent, which has earned it the nickname the universal solvent. This is important because life needs a solvent to enable key chemical reactions. This becomes more significant when I theorize about why aliens haven't visited us yet, later in this video. Life doesn't just need water to survive. Life needs water to begin. And those two things are very different. So we know that an alien world would need water to get started, so we can assume their world would likely be similar to Earth. Now of course, water is the best solvent that we know of, but could life start without water? Well, we don't know. Not really anyway. But we can assume that it's likely to be possible. And we can look at a place similar to Earth with lakes and rivers, but still, no water. This is Titan, the largest moon of Saturn, and the lakes here are made up of liquid ethane and methane. If life was discovered on Titan, it would mean that life can start relatively easily and in a different way than we previously expected. So far, life hasn't shown up on this world, but more searching is required before we can rule out the possibility. So the chances are the alien homeworld will likely be a rocky world with a large water mass, much like Earth. However, just because Earth is perfect for us, that's because we've evolved to suit Earth. Any differences in our environment would have caused a different evolutionary path. So for this, I think water is simply what we're looking for. What about the star though? Up to 85% of star systems have more than one star orbiting the other, and the most common star is an M-class star, aka a red dwarf star, making up around 3/4 of all stars. Which is unfortunate, because finding a world with liquid water around a red dwarf has its problems. Around any star is an area where the temperature is not too hot and not too cold. It's just right for water to exist in liquid form. This is called the Goldilocks zone. However, there is another zone around a star where planets tend to get tidally locked, meaning one side of the star will always face towards the star. On one side the planet is scorched with radiation, and the other never sees the light of day and is forever frozen. However, we would find a habitable strip around the diameter of the planet. But as hopeful as this is, it might be habitable through this regional strip, but it's unlikely that life can get started here. So again, we find ourselves looking back at our solar system as the base idea for what to look for when finding alien life out there. I believe there's more to this which might just help explain the Fermi Paradox. So far through this we've been looking at limiting where aliens could exist and what their home world would look like. While the Drake equation was also an attempt to use what we know about life on Earth and estimate how likely advanced alien life exists out there in the universe. The Drake equation estimated there could be anywhere between 1,000 and 100 million civilizations out there. Not just life, but some form of intelligent beings that are advancing with technology in some way or another. But this is where the Fermi Paradox comes in. If there are so many potential civilizations out there, why is there no evidence of them? And I don't just mean why haven't they visited us. I mean if civilizations are so common, then the oldest civilization would have a tremendous advantage before us, likely to have been a spacefaring race before we humans even evolved as our current selves, Homo sapiens. A civilization surviving millions of years, maybe even a billion years before us, would have a massive effect on the universe, draining stars for energy and even existing around us maybe. But we have seen zero convincing evidence for an alien race existing or even its effect on the environment of space, leading people to conclude that if life is out there, then it hasn't advanced much further than we have. Which is weird if you think about it. The universe is about 13.8 billion years old, Earth is about 5 billion years old, life formed on land about 500 million years ago, and our species evolved 300,000 years ago. People wonder how advanced we would have become if the Dark Ages never happened, and that would only have been 900 years ahead in technology. Well, imagine what it would be like if humans evolved earlier, or on a planet that formed earlier. There's only really two options if life is everywhere. And that is, if a civilization becomes so advanced, they eventually disappear. Maybe ascending to a higher plane of existence, or transferring consciousness into a computer or something similar, to essentially become immortal, but are basically disconnected from the universe. On the flip side to this, yes, the dark side, the Great Filter. The idea that at some point we will hit a barrier, something that prevents technology allowing us to travel far enough to encounter another race. An example would be the hopes of travelling faster than the speed of light. If that's not possible, then we will be limited. Or another great filter is war. Looking at creatures on Earth, herbivores are not as likely to become intelligent. I mean, they don't have to be. They eat, they run away, sometimes they're social, but not always. Predators, on the other hand, are far more likely to be intelligent, because hunting requires so many skills and a lot of planning. So an intelligent race is most likely to be carnivorous, or maybe more likely omnivores. The problem here may arise with war because these creatures are usually warlike or territorial. The problem presents the idea that no species can settle their differences without war, and weapons become so powerful so quickly that we wipe ourselves out before they can save themselves. And with our past wars, it's hard to at least dismiss this possibility. I do believe in the Great Filter, however, if that filter is ahead of us, I would imagine other civilizations would have had a chance of getting further out into space. We already have a concept of an engine using nuclear explosions to propel ourselves to other worlds. It was called Project Orion back in 1958, an engine that would allow us to explore other star systems. Now, if thousands of races get to our stage, at least one of them might take on that challenge, and therefore have a greater chance of expanding the galaxy and the universe for millions of years. But then we go back to the Fermi Paradox. Why don't we see evidence of them out there, or their effect on the galactic environment? This leads me to believe that the Great Filter might actually be behind us. We've already passed it. The Drake equation is great, but obviously without extra examples of life's existence, its potential is limited. Any number of great filters could sit anywhere on the Drake equation, and I believe we have passed at least one of these potential great filters. With the missing data, the Drake equation has had to make a few assumptions. One of those assumptions was the number of planets where life actually appears on a suitable world. And that's the point. Habitability is different than where life may actually form. We know that on Earth, life formed in the ocean. As we know, water is a great solvent for mixing many different things. Geysers on the ocean floor provided the perfect mixture for life to begin, but could there have been one other element required for life to start? Or at least help life to take its first form? What if we need a spoon? Not literally, I mean something to mix all of Earth's oceans, stir it all up. Of course, I'm talking about our moon. Our moon is large enough that it seriously affects the tides of our oceans, never really allowing things to simply settle. And back when life first formed, the moon was much closer than it is today, having an even greater effect. But the problem with this idea is that our moon is rare and unique. I mean, Mercury and Venus have no moons at all. Mars has tiny moons compared to ours, and only the gas giants can rival our moon against theirs. So how did we end up with such an exceedingly large moon compared to our planet's size? When the solar system was first formed, Earth didn't really form here. Instead, it was another planet that would later become Earth after a collision with another planetary object, about the size of Mars. After this collision, much of the debris formed rings around the newly formed planet, Earth, and these rings eventually became our moon. This way to form a moon is actually quite rare, and the event is even less common to happen on the inner planets than with planets much further away like Pluto and its moon Charon, which is practically a bi-dwarf planetary system rather than just a moon of a dwarf planet. If the large moon to planet ratio is an important requirement for life to get started, then the chances of finding life would not require a planet like Earth, but a life-starting solar system equal to our own. That is what we need to be searching for. And suddenly, it feels like we are once again alone in the universe. Maybe we are alone, but obviously life started here on Earth, and therefore could happen again. Or even if life's beginnings is the first great filter we faced, once life starts, it doesn't have to become technologically advanced to become biplanetary. And it's unlikely but again possible that life didn't start on Earth. The theory of panspermia suggests that life could start on a planet and move from one planet to another through asteroids. Let's say life started on Venus before it became Hal. An asteroid strikes it and rocks fly into space. These rocks are carrying extremophile microscopic organisms and could survive the initial impact, the journey through space, and even survive the landing into Earth's oceans, seeding Earth with life from Venus. Alien life. Don't get me wrong, this is just an example, but it's easy to get lost in the time before us. The universe's history goes back 13.8 billion years ago, and that truly is a long time, but it's absolutely nothing compared to the time that we have left in our universe. Thinking about it this way, we are extremely early in the universe's full story. And even if we are the first advanced life forms here, seeds from Earth could be out there seeding other worlds for the billions of years that life has existed here. I've always wanted to make this video, so let me know what your thoughts are. I've always wanted to make a video about my theory about the moon starting life. Thank you for watching, and I'll see you in the comments.